to meet you. My name is Ezekiel.
Ezekiel. I'm Mrs. B.
Nice to meet you.
Nice to meet you.
Good to meet you, Mrs. Sharon. Hello, my name is Ezekiel, and this is my science project on the infinity mirror. I'm fascinated by illusions, and when I came across the mirror, I had to know how it worked. But the biggest question that I had was whether color would affect the depth of photon. In my research, I learned that light is made out of these things called photons, which travel in a straight line. If you're wondering what photons are, scientists still do not know exactly what they are yet, but we do know that photons are electromagnetic energy, and we use this electromagnetic energy daily. When light hits a reflective surface like a mirror, all the photons bounce off the mirror at the same angle back into our eyes. This is called the angle of indice. It is this angle of indice, angle of reflection, that allows you to see yourself in a mirror. My hypothesis was that green light would be the furthest color you would see in an infinity mirror because it is the brightest color in the rainbow spectrum. When it comes to light, the longest visible wavelength is around 700 nanometers and appears red. Visible light starts at around 400 nanometers, and light can travel as fast as 186,000 miles per second in a vacuum. I began building the mirror by putting together the box ordered from Amazon, placing the mirror in the back of the box, cutting a hole on the top of the lid, and cutting the plexiglass out. I placed the mirror film on top of the plexiglass and put it inside the lid. Then I took the LEDs and taped them on the inside walls of the box. Then I took the lid with the plexiglass and put it on the top of the box. I taped the lid to the box and turned the mirror on. The mirror works when the lights are on, and the light bounces off the mirror and hits the plexiglass, where some light escapes and the rest bounce back. The light that escapes the mirror is what we see, and the light that bounces back creates the infinity effect. When I collected my data, I did the experiment in a dark room to count all the rings. I learned that my hypothesis was not supported. I believe the green light would create more rings in infinity mirror, whereas red would create the least. But in fact, all the rings were the same amount. Interestingly enough, the red light was the hardest to see and the blue light was the easiest to see, but the results still do not support my hypothesis. One thing I did not expect was for red light to have the same amount of rings as green. I had fun building the mirror, although some of the mishaps I had were that my LEDs would not work and my mirror shattered. I would like to thank my parents for helping me and for supporting me throughout the process. I would also like to thank you, the judges, for coming out, for taking your time to come out and listen to my experiment.
Great job. Good job. Good job.
Any questions?
Yeah. First, I wanted to say good job. I know it's not always easy standing in front of people and presenting, but you did a great job. And can I first ask, how long did your board take? Oh my gosh, those are all like little tiny squares.
I know. I had fun. This took me 2 days to do. I actually enjoyed it because when I was doing it, I was reading an audiobook, and I love reading audiobooks and like doing something while I read it. So I enjoyed. Another thing, it was easy to do because my sisters were at ballet, my mom and dad were at work, so it was quiet, peaceful, and I didn't have to do anything exactly.
Mm-hmm.
Took me 2 days to tape all this down.
You taped it? You didn't glue it?
Well, the first part I taped, my dad showed me when he came home that glue will be easier, so.
Okay. Oh, that's a lot of tape. Okay, so 2 days to get it all on there. How long to cut every little square?
About 2 hours, 1 hour.
Oh, okay.
Because I had that,
Did you use like a paper cutter?
yeah, the paper cutter.
Yeah. Oh, okay.
I cut way too many.
It was pretty impressive. That was one of the first things I noticed. And can you tell me again what made you decide on this project?
Well, I wanted to do something interesting and unique instead of like flowers and space like that, and I thought illusions, because they're cool, they trick your mind, they do stuff like this, if you stare at it, it shakes.
Mm-hmm.
I'm like, they're cool, like, it looks like it goes on forever, so I just decided to pick it.
So why did you think green would be the color that has the most
I thought green because green is the brightest color. Green is the brightest color in the rainbow spectrum. Like in the dark, it's the easiest to see in the dark.
Okay.
The brightest one, the brightest color we have in the rainbow spectrum. Red is, as you can tell, like very dim. Like when you have a flashlight, you have like white light, and then you turn to red, it turns very dim. I thought red would be the least, but it's very dim. That's why I thought green was very bright.
Did you know that green was the brightest one on the rainbow spectrum before you started this experiment, or was that?
I
something you
did
learned along-
because a while ago when I had what are they called? The glow sticks. Glow
Okay.
sticks. There was red, blue, green, yellow, and stuff like that. I took them out. Then I noticed that green is like the brightest, like you can see really easily, while red is like harder. Blue's pretty bright too, but when I look compared to green, green was a little brighter. So when I saw that, then I researched it after. I'm like, oh, green is the brightest color on the rainbow spectrum. Rainbow spectrum.
Didn't know that. And then when you built the box, did you, because from the looks of your paper, you ran the experiment one time and just counted it one time. Did you do it more and we were just missing that you did it a couple times and the results just didn't change, or can you explain that?
I did go over it twice,
Okay.
just to make sure. I flipped through the colors, I wrote them down, then I flipped through it again just to make sure, like really looked in the back to see it was just 7.
Okay.
I was telling my mom, maybe I need a paragraph in results. My mom's like, it's good how it is, leave it. I'm like, it's not good. I hate that the results are like that. I wish they were better.
It was just a question. And for your own curiosity, have you moved the LED lights from the back of the box to the front of the box to see if that changes how many rings you can see?
No.
I know that would be a second variable for this experiment, but just for curiosity purposes.
No, I couldn't because on the back there's like this glue. Once you put it down, it's stuck there for life.
Okay, that makes sense. Answers that question. Do you know why that picture shakes when you look at it?
I'm guessing because it's all the colors and so much to take in to look at. That's my guess. I'm not entirely sure. The only reason that's there is to get your attention.
That's a good attention getter.
Did you do any research on, and this is kind of outside of it, but what I found interesting when reading your paper was how the eye responds to color, the human eye.
I don't know how to answer that. Because every light has a wavelength. Red has longest wavelength, like for example, like it's slow, while violet is really short and like that's why I don't know how to explain it exactly.
I think you're doing a good
But-
job so far, so keep going.
But the wavelength affects your eyes. Like there's the visible wavelength and there's a visible wavelength. There's like the. It's so hard to explain. It's like what we see, but like sometimes the wavelength gets so like long we aren't able to see it, and the wavelength gets so short we aren't able to see it. That's why we have ultraviolet light, and it helps us see things better. We use it in many things. We use ultraviolet light in X-rays and stuff like that. But yeah, that's the best I can explain it. I'm gonna actually
No, that was,
look at that.
Yeah.
that was really good.
Yeah. Yeah. What was your favorite part about doing this?
Probably the was. It was fun. I didn't have to stress with this.
That's fair. Did you have any help from any?
Yeah, my dad helped me cut this out. Like I did not really, because the hardest part, my dad did it because it was so hard. You had to take it, because you read this, right?
Yes.
You had to take it and actually bend it, snap it.
Okay.
So like the piece like shot on my glasses.
Yeah.
That was really stressful. Also the box, having to cut it and measure it, because my dad is a construction worker. He made me struggle. He didn't exactly give me the answers with this. How to measure it correctly is like figure it out. On my experiment, like you help me at least a little bit. He's like, you can have it at least this small, man. So I did it, and I realized that, well, I didn't actually have to do it this small because the plexiglass doesn't stay that good. Could have done it a little wider because you can see the lights better. Though the disappointing thing was one of the mirrors broke. Out of subject.
I do, yeah, sorry.
Asking who helped you,
Oh.
if you had help.
I do think though too, watching it, I think you, and the colors, the red is definitely fades quicker. It is harder to see that while it has 7, so maybe like as it may have 7 rings, did you notice that some were brighter in the further back and some faded? Am I asking the right question?
Like how it's faded back all blue, you can see in the back of the
Yeah.
Yeah.
I don't know how
So
to.
that one, I see, like, I don't see as many in that one as I do in that one.
This is at the brightest color. That's when I found out I could see it. But what I did was when I dimmed it all the way down, red was only 5, blue was originally 7, green was 6, 5, something around there. My mom's like, we're doing it right. So why can't
Okay,
I do it?
can you show me the green again?
The green, blue. Like you can see how green in the back. You can see it a little better. The blue is a little harder.
Yeah. And
I don't
the red is even
understand. I
less,
don't.
though.
I don't understand how it was easiest to see. I don't understand it, but it was in the dark.
And then do the red. Yeah, see, I can barely see the,
Yeah, I can't hardly see past.
If we turn off the lights, like I don't
Yeah.
know. If I turn off the lights.
it's still, I mean, it's visible, but barely, in comparison to the other 2 colors. Okay.
I didn't count the first string. I didn't count because it's the original. I counted
Okay.
the actual. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7 is barely back there. Can you see it? Like if you actually look very close, you can barely see
Yeah.
7.
Yeah.
Look, if I change to green, you can see 7 easily.
Oh, yeah.
And then blue, you can still see it.
I still think, like, I do think the green is the brighter when you're looking at it. Like, I can see farther. I can see further back with the green. I mean, I know that you're still saying it's 7, but I do think that's interesting.
I know, but when I was doing it, how I was in front and it was completely dark. Like, you couldn't see a front in front of you. The room I went in, blue was somehow easier to see. I didn't get it.
Okay.
Like I can see how right now it's brighter, but like I don't get it. Like red, you can still see back. I mean, red is harder.
Yeah.
Yeah.
But you can still see it. When I dimmed it down all the way, it's dimmed down, you can barely see anything. Green,
Okay, you can still see quite far.
I can barely see 6, and blue, 6, barely 7.
Okay.
That's fascinating.
So you were just basing it on the amount of, how far back, counting the lines of them,
Yeah.
not the, whether it was dim or not.
Yeah.
Okay.
While I was doing this, I'm like, I found better things in how back. Like when I was putting in the LEDs, I'm like, would brighter LEDs or the mirror film that's on top. I'm like, maybe 2 mirror films you could see better in the back, or like 3. I found better questions to be like in this, but I was already so far in this one, I'm not even gonna start over.
How many did you expect to see? You expected green to be
I didn't-
4, but how much do you have?
I didn't actually think of that. I only thought green would be the most, red would be the least. That's all I thought. I didn't think how much to see.
Do you wear glasses normally or contacts?
No.
Do you think that if somebody did wear glasses or they have better eyesight than you, that they might be able to see more?
Well, maybe. I don't know about that. Well, hold on. I'm gonna have to get Moses down here.
I don't know what Moses' vision is. I'm just curious because, like, sometimes I'm like, can I actually see 8, or is that my mind telling me that I know there's
I know,
8
like,
back there?
it's almost like tricking you. It's like focus. Like, cause I have really good vision. I have the best vision out of my family.
Mhm.
And out of most people that I meet, like I can see better, see further, see more details. I have really great vision, so I'm able to pick. My mom wasn't able to really see it, but like here is much easier. Like if you count 1, 2, 3, 4, 5, 6, like 7 is barely there.
Mm-hmm.
The camera had a very hard time with blue for some reason. Like
Yeah, it
you
looks
still see
almost like
some
an
of like
illusion.
over here is
Mhm.
easier because the camera actually focuses and actually captures it, while your eye just looks around with it. Yeah.
Yeah. Okay.
Thank you so much.
Thank you. Good job.